Okay. So, um, what conditions would be necessary in order to have both an absolute maximum and an absolute minimum? This is called the extreme value theorem. All right. So it says, and this is the theorem, if f is continuous on the closed interval, a to b, then f has both a maximum value and a minimum value on the interval. That's it. No differentiability this time, like with the mean value theorem and Rolle's theorem. You don't have to worry about that. It just has to be continuous. All right, now, one thing you need to keep in mind, these extreme values could occur at an endpoint. All right, so not necessarily at a relative max or min. Okay, it could be at an endpoint, so we have to check those. All right, now, interesting part here, this is what example 4 is all about. The hypothesis says if you have if you're continuous on a closed interval, then you're going to have those. It doesn't say if it's not continuous what would happen. You still could have max and mins even though it's not continuous. And so that's not the way if then statements work, right? If the conditions met, then we're going to follow up. If the conditions not met, who knows? Fair game. All right. So that's what we're looking at here on A, or example 4A. It says for each graph, explicitly state where the hypothesis of the EVT fails on the interval from 0 to 3. Then determine if the function has an extrema on the interval or not. Okay. So of course we have a discontinuity. EVA fails due to due to discontinuity at x equals 1. Okay. However, we still have maximum and minimum values. All right. You can see looking at the graph, there is an absolute max of 4 when x equals 1. Okay. And also, we have a minimum. We have an absolute min of, looks like about a half, when you say, of a half at x equals 0. There we go. And so, which is really cool because like one of our endpoints was an absolute minimum. We said that could happen, and then the maximum was not an endpoint, but it can be. All right. Now look at B. We've got an issue. Look at like at 1.5, right? All right. So EVA, EVA, EVT. What the heck's the EVA? All right, EVT. EVT fails due to discontinuity. And that's misspelled. Done. At x equals 1.5. I'm making a video. Now, I'm not going to edit that out. Okay, and then so this one's really interesting because we have an absolute max. So an absolute max. All right, so absolute max. I don't know what the heck was going on there. Hey, look, I got a max of I don't know, 4.5, maybe. I don't know. Hard to tell. 4.5 when x equals 0, and there's no absolute min. Now you're like, well, how could that be? Well, I mean, look at the bottom here. There's an open circle, so there's no absolute min. There's no stopping point, and that wouldn't happen if it was continuous. All right, if it's continuous, you're always going to have values throughout, and so you couldn't have this open circle situation. Okay, now this one's really wild. All right. Now, remember, it's got to be continuous over the whole interval, including the endpoints. So we've got a mess at both endpoints here. so EVT, what is it doing that? EVT fails due to discontinuity at x equals 0 and at x equals 3, because there's a asymptote there. X equals 3. All right. And check it out. There's no max or min. No absolute max or min at all. Because the place where we possibly could have had a maximum has an open circle, and then the asymptotes creating an issue for the minimum. All right. Now, okay, what about this one? All right, the problem are the endpoints. Okay, so we needed to be a closed interval, and this is an open interval from 0 to 3. All right, so EVT fails due to, I want to say open circles, but we've been saying discontinuity, so we'll do that again. So due to discontinuities, is that okay? I think y'all get the point. At x equals 0 and again at x equals 3. However, it does look like we have max and mins this time, right? They happen just in between. All right, so there's an absolute maximum value of 4 at x equals 1 and an absolute min of, I don't know, maybe -1. I don't know. It might not be that low at x equals 2. Good. Okay, good. So extreme value theorem gives us knowledge of when extrema occur, but how will we find them algebraically when given the equation only and without the benefit of the graph? So our next question will be, how can we identify all values of x where extrema value occurred? That's what we're going to be doing next.